Hello everybody, in today's video we are going to be looking at trigonometry and how to solve for a side length or an angle when we only know one side. So previously we've looked at right angle triangles and how to find the third side if we know two of the sides using Pythagorean theorem. But today we're going to look at what we do if we only know one side. We can still solve as long as we know one of the angles. So the first step of this process is being able to identify the sides. So if we look at this triangle right here, you see that I have labeled the sides. They are always based off of the angle that we are given or the angle that we're trying to find, and we use the theta symbol for this angle. The hypotenuse is always across from the right angle, so usually that is the first one that I will go to. It's the one that is across from the right angle. It is called the hypotenuse. The opposite side is always opposite of our angle that we are given or trying to find. So opposite our theta symbol. And the adjacent side is beside it, or sort of just the last side. So I usually start with the hypotenuse. I look for the side across from the right angle. Then I look for the side across from the angle that I've been given or trying to find, and that is the opposite. And then the last side is our adjacent. So let's practice this naming first before we jump into looking at the actual functions. So if I have this angle here, then the first thing I'm going to do is find my right angle, and I'm going to go across from it, and this is going to be my hypotenuse. I then am going to go across from the theta angle, and this side is going to be the opposite, and my last side becomes my adjacent. Let's look at another example. So again, I'm going to find my right angle, I'm going to go across from it, and that is going to be my hypotenuse. I'm going to go across from my other angle, and that is going to be my opposite, and my last side is my adjacent. Now for this one, pause the video, try and label the sides yourself, and then start the video when you're ready. So again, my first step is to find the hypotenuse. I'm going to look across from the right angle, and this side is my hypotenuse. The side opposite my angle is the opposite side, and the last side is the adjacent. So now that we're able to identify the different sides, we can now look at the trigonometric functions. A kind of neat way of remembering these is using SOHCAHTOA, which spells out all of the different formulas we can use. So stands for the sine function is opposite over hypotenuse. And then CA stands for the cosine function is adjacent over hypotenuse. And TOA stands for the tan function is opposite over adjacent. So depending on which side you've been given and the angle that you have, you can find out the missing piece. So for example, if I am looking for the opposite side and I've been given the adjacent side, then I'm going to use the tan function because it uses opposite and adjacent. If I'm looking for the hypotenuse and I've been given the opposite, then I'm going to be looking at the sine function because it uses the opposite and the hypotenuse. So the steps for finding the side when given an angle is to start with the angle that's given, not the 90-degree one, the other one. We're going to identify all of the sides that we have and what we want. Choose the function that makes most sense for what we're given, and solve using cross multiplication. So let's take a look at an example. The first thing I'm going to do is label all of my sides. So I know that this 40 is going to be my hypotenuse because it is across from my right angle. This side is going to be my opposite, and the last side is my adjacent. The question is asking to find side A, which is this side here. So that is side A. So this means that I am given the hypotenuse and I'm looking for the opposite. So I don't really care about the adjacent side. I'm not looking for it. I'm not given any information about it. So let's look at our different functions and see which one uses the opposite and the hypotenuse. The sine function. So we're going to be using the sine function formula because it uses opposite and hypotenuse. So sine of my angle is equal to opposite over hypotenuse. So that means sine of 30 is equal to A, that's the side we're looking for, over 40. And now that I have my formula set up, I can cross multiply. So we're going to think of this side as being over 1, and I'm going to cross multiply in order to expand this out. So 1 times A is just A, and this side is going to be 40 times the sine of 30. And I get 20. So side A is 20. Let's look at another example. So my first step is to label my sides. So this side is going to be my hypotenuse. This side is opposite. So this side is adjacent. Now it's asking me to solve for side B, which is this side here. So I don't really care about the hypotenuse. I'm not given any information about it, and I'm not looking for it. So I want to use the function that uses opposite and adjacent. So opposite and adjacent is the tan function. So tan of my function is opposite over adjacent. So in this case, tan of 52 is equal to side B over 13. And I'm going to use cross multiplication to expand. Again, we're thinking of this as over 1. So 1 times B is B, and this side is going to be 13 times tan of 52. And I get 16.64 if I round to 2 decimal places. For this one, pause the video, try it out on your own, and then start the video when you are ready. Okay, our first step is to label the sides. So this side is going to be my hypotenuse. This side is opposite, and this side is adjacent. And I am looking for side C, which is this side here. So I don't really care about the opposite side. I'm not given any information about it, and I'm not looking for it. So I want to use the function that works with adjacent and hypotenuse. And that is the cosine function. So cosine of our angle is adjacent over hypotenuse. So cosine of 27 is equal to 21 over C. And we're going to think of this as being over 1, and we're going to cross multiply. This time I get 21 equals C times cos of 27. So my letter this time is not on its own. So I need to make it on its own. And in order to do that, I need to get rid of this times cosine 27. So in order to do that, I'm going to divide both sides by the cosine of 27. And that way this will cancel, and I'm left with 21 divided by the cosine of 27 equals c. And we end up with c equals 23.57 if we round to 2 decimal places. So now let's take a look at what we do if we want to find the angle when we're given two sides. The first couple steps are the same. You want to identify the angle you are solving for and use that to label the sides. So our first step is still label the sides. Choose which trigonometric function you're going to be using. And then we're going to cross multiply and use the inverse in order to find the angle itself. So for example, if I want to find angle A, I'm looking for this angle here. So I'm going to find my hypotenuse, which is this side. My opposite is this side, and this side is my adjacent. So in this case, I'm given information about the hypotenuse and the adjacent, so I don't care about the opposite side. The function that uses adjacent and hypotenuse is the cosine function. So cosine of my angle is adjacent over hypotenuse. So this time when I fill out the information, I'm still going to have my angle as the unknown. My adjacent is 15 and my hypotenuse is 30. So in order to figure out what theta is, what my angle is, I have to get rid of the cosine. And in order to do that, I'm going to do the inverse. So I'm actually going to find the inverse of 15 divided by 30. You'll generally find this function above the cosine function on your calculator, so you may need to use a shift button on your calculator in order to use it. And we get an angle of 60 degrees. Let's look at another example. So I am looking for angle A, which is right here. So this side is going to be my hypotenuse. This side is going to be my opposite, and this side is my adjacent. So in this case, I've been given information about the opposite and adjacent side, so I don't really care about the hypotenuse. The function that uses opposite and adjacent is the tan function. So tan of my angle is opposite over adjacent. So tan of my angle is going to be 2 over 1. And again, to find the angle itself, we're going to use the inverse. And I get an angle of 63.43 if I round to 2 decimal places. For this one, pause the video, try it out on your own, and then start the video when you're ready. In this example, we're trying to find the angle B, which is this angle right here. So that means this side is my hypotenuse, this side is my opposite, and this side is my adjacent. I'm given information about the opposite and hypotenuse, so I don't really care about the adjacent side. The function that uses opposite and hypotenuse is the sine function. So sine of my angle is opposite over hypotenuse. So sine of my angle is 4 over 12. I'm going to use the inverse function to find out what my angle is. And I get 19.47 if I round to 2 decimal places. And that is how you use the sine, cos, and tan functions in order to solve right angle triangles.